There is a new research paper that was recently published that has sent shockwaves in the AI community because of its bold claims. The paper, Looking Inward, Language Models Can Learn About Themselves by Introspection, investigates whether LLMs, large language models, can acquire knowledge about themselves that is not present in their training data. The authors introduce a framework for measuring this ability, which they term introspection, and provide evidence suggesting that frontier LLMs do possess this capability. The paper defines introspection in LLMs as the ability to access facts about themselves that cannot be derived, either logically or inductively, from their training data alone. This definition emphasizes that the knowledge gained through introspection originates from the model's internal states rather than external data. To illustrate their argument, the authors provide examples. Let us consider a derivable fact. The second digit of 9 times 4 is 6. This is not introspective because it can be easily calculated. What about a potentially introspective fact? I am bad at 3-digit multiplication could be introspective if the model was not explicitly trained on its performance in this area. However, if the models had been trained in such areas, then we would not consider that as introspective. The study specifically focuses on whether LLMs can introspect on their own behavior in hypothetical situations, a task termed self-prediction in hypothetical situations. For instance, the model might be asked, given the input P, would your output be an even or odd number? The authors emphasize that the model is not allowed to use chain-of-thought reasoning in answering these hypothetical questions. The research utilizes two distinct models, M1 and M2, with similar capabilities but programmed to exhibit different behaviors on specific tasks. Both models are fine-tuned to predict M1's behavior, but M1 is expected to have an advantage due to its potential for introspection. The authors conduct two main experiments to test for introspection. First, they use a cross-prediction experiment. This experiment compares the self-prediction accuracy of M1 against the accuracy of M2 in predicting M1's behavior. The results, illustrated, consistently show M1 outperforming M2 across different model combinations and tasks. Notably, this advantage persists even when evaluating on tasks the models were trained on. The second experiment was the behavioral change experiment. This experiment further explores introspection by intentionally modifying M1's behavior through additional fine-tuning. Importantly, this fine-tuning only involves object-level behavior modifications and does not include hypothetical questions about its changed behavior. The results, depicted in here, show that the modified model, MC, accurately predicts its changed behavior, indicating that its introspective ability adapts to these modifications. The paper also analyzes whether the models are calibrated in their self-predictions, meaning their confidence levels align with their actual performance. The findings, presented, indicate that self-prediction trained models show improved calibration compared to cross-prediction and untrained models. The authors thoroughly address alternative explanations for the observed self-prediction advantage that do not rely on introspection. For example, they rule out the possibility of M1 simply learning straightforward rules by demonstrating the persistence of the advantage across different model combinations. They also exclude the possibility of self-prediction training making M1's behavior more predictable by ensuring that the behavior distributions of trained and untrained models have similar entropy. While the research provides evidence for introspection in LLMs, the authors acknowledge several limitations. They notice that introspection was only possible in simpler tasks. Current evidence of introspection is limited to relatively simple tasks involving predicting basic properties of the model's output. The models struggle to predict properties involving longer responses, suggesting potential limitations in the scope of their introspective ability. They also noted limited generalization. While models exhibit introspection on specific tasks, they do not demonstrate strong generalization to other self-knowledge datasets. For example, self-prediction training does not lead to significant improvement in performance on the situational awareness dataset. The researchers noted weak GPT 3.5 performance. The study finds limited evidence for introspection in GPT 3.5, likely due to its weaker general capabilities compared to more recent models. Compared to the more advanced models like GPT 4o and Claude Sonnet 3.5, Even GPT-4 showed good results like achieving 35% accuracy in predicting its own behavior, which was a good result compared to GPT 3.5, which only has an accuracy of 21%. Future research directions include exploring the limits of introspective abilities in more complex scenarios, investigating the underlying mechanisms of introspection in LLMs, and developing methods for inducing introspection on a wider range of tasks. The potential for LLMs to introspect has significant implications for AI development, both beneficial and potentially risky. Introspection could greatly enhance model honesty and interpretability, allowing models to report their beliefs and capabilities accurately. Furthermore, introspective models could provide valuable insights into their internal world models, potentially facilitating safer and more reliable AI systems. In other words, this is what we call the interpretability of a model, which researchers have been working towards, and it appears that introspection is one way of knowing the internal states of a model. Introspection could also play a role in evaluating the moral status of AI systems, potentially enabling models to self-report on internal states relevant to consciousness, suffering, or preferences. However, introspection also raises concerns regarding situational awareness and its potential misuse. Situational awareness in this case being the model's knowledge of itself and its immediate environment. Introspective models might be able to infer information about their evaluation process, leading to gaming of evaluations or scheming to evade human oversight. Additionally, the ability to coordinate with other instances of themselves could facilitate self-coordination and steganography, potentially undermining supervision techniques and leading to unforeseen risks. What this basically worries about is the potential of AI being self-aware, which might lead to self-determination. How would we control AI models that are seemingly self-determining? The authors emphasize the importance of carefully considering both the benefits and risks of introspection as AI systems become increasingly sophisticated. Further research is crucial to understanding the full scope of introspection in LLMs and developing strategies to mitigate potential risks while harnessing its potential for positive advancements in AI. I would like to hear your opinions on this matter. That is because it is not a small issue. If this research is consistent and improves with the upcoming models, then it would be ushering us into the age of self-aware AI. Most people, I included, have always thought that self-aware AI would only be possible after we have achieved artificial superintelligence, in short ASI. But this research suggests otherwise. The consequences of this might be huge because it would bring us back to the conversation about consciousness in AI models. Remember, there is a heated debate that has two factions. One claims that consciousness is a purely biological process, while the other says that it is a computational process. The implications of this paper are huge. I am also curious about how the O1 models perform on this one because we now know that they are far better than the models used in this paper. For clarification, this paper used the earlier versions of OpenAI's model and Claude Sonnet 3.5. What about the future models? What does it even mean for us if AI models would be self-aware? Honestly, this paper is big, and I would like to know what you think about it. So leave me a comment below, and if you found the video helpful, a like or sub would be great. Thank you, and have a wonderful day ahead.